So let's say you have a projectile launched with an initial velocity v0 and at an angle of theta. So we can actually break down this velocity right here into a triangle like this: v0, v0x, and v0y. Makes sense, right? Because like when you're pulling at an angle, you're not only pulling horizontally, but you're also pulling vertically and vice versa. So if you pull completely horizontally, there is no velocity that is going up. So yeah, v0 is y and your v0x is max. But let's say if you're pulling completely vertically like this, your there will be no movement in the x-axis. So your v0x will be 0 and your v0y will be maximum. So now given this is a given formula. D is equal to v initial times time plus 1/2 at squared. So if we want to get the distance given the velocity and time across horizontally, we have to convert everything in terms of x, so vxt. And since it is a rolling projectile motion that acceleration is always zero horizontally, the velocity will stay the same horizontally. So yeah, this since a is zero, this part will be completely gone. But we still need to simplify v0x. So let's go back to triangle. So to rewrite v0x, we can use the cosine function. So as we learned, cosine is equal to adjacent over hypotenuse. So it is now, so from this triangle, it will be v0x over v0. This is your adjacent and this is your hypotenuse. So rearranging, we will get v initial x is equal to v initial times cosine theta. So substituting back, we get dx is equal to v initial times cosine theta times time. And that's the first formula. Now, the second formula in terms of y, v initial y times time. Now, a in proj, in this case, is negative g. Okay? G is never negative 9.8. Okay, the guys, that's wrong. But acceleration will be the one changing the sign of g. So yeah, well, I'll just keep this. So, substituting back a is equal to negative g, it will be minus 1/2 g t squared. Now, to simplify v0y, imbis na cosine, ang gagamitin naman natin ngayon ay sine. Since we're dealing with y. So, from the triangle, since we know that sine theta is opposite over hypotenuse, it's v0y over v0. Rearranging, we will get v0y is equal to v0 times sine theta. So, substituting, we will get dy is equal to v0 sine theta times time minus 1/2 gt squared. So, yeah, that's the derivation of the first few equations. Yan. So now looking at the formula for dy for the height, v naught sine theta time minus 1/2 gt squared. Notice, it's actually a quadratic equation, but instead of x and y, your y is dy and your x is time. So this is actually just a graph of your height as time changes. And v naught sine m. This is like the slope and this is just some constants, and this will just change the position of the graph. So this is basically dy. Yeah, and don't forget v0 and theta. So now that we know that this is a quadratic equation, if we want to get the time given a certain height, I'll just substitute it with h. So equal to v naught sine theta t minus 1 half gt squared. If we want to get it at a certain height, we will just use the quadratic formula. So moving, transposing h, we will get v naught sine theta t is 1, ay, wait, yeah, that's good enough, is minus h equals 0. So we will just use the quadratic formula, but instead of x, we will use t. So our b here is v naught sine theta, since it's the one beside t. So it's negative v naught sine theta plus minus b squared, which is just v naught squared sine theta squared. Oh wait, I have no space. So as I was saying, t is equal to negative b, which is v naught sine theta, plus or minus square root of v naught squared sine squared minus, so 4ac. So our a here is minus 1 half g, and our c here is negative h. So it's negative 4 times negative 1 half g times negative h all over, and since our a is the one beside the t squared, it's negative 1 half g. Negative 1 half g times 2 is just g, and negative g. And the negative cancel out. So we will get v naught sine theta plus or minus v naught squared sine squared theta minus, simplifying this, that's plus 2gh. I wait, no, that's minus 2gh. Also, there's three negatives. Yeah, yeah, minus 2gh all over g. So yeah, if that, this is the formula if you want to get the time given a certain height, which is h. But if you just want to get the time at the maximum height, so as we know, the this formula here, as we got earlier, is just a projection of the distance as time changes. If we want to get the maximum height, at the time at the maximum height, yeah, since we know it's a quadratic equation, we can actually just use the formula for the coordinate of the vertex, which is negative b over 2a. Remember, our x in this case is the time. So our substituting, our b is v naught sine, and our a is negative 1 half g. So canceling, it becomes v naught sine over g. So that's the formula to get time at the maximum height, since this is just negative b over 2a. So yeah, at this point, t is equal to v naught sine theta over g. So yeah, and what else? So yeah, going back, we will now get the formula for the time uh, where the projectile is at 0. So first, yeah. So since our height is 0, the negative 2gh will be eliminated. So it will become v naught sine theta minus v naught squared sine squared over g. And notice that the square root will just cancel. So it is v naught sine theta plus or minus v naught sine theta. Yeah. So g. Now, how will we decide if we're gonna use the plus or the minus? So since we are looking for the further end, this part of when it will land, we will use the plus. So, and notice that if you use the minus, it will actually become v naught sine theta minus v naught sine theta, which is 0. So that means time is equal to 0, which is the other point or the start. So yeah, your formula to get the time when it hits the ground is 2 v naught sine theta over g. That's for when it hits the ground. So yeah, after you've gotten the time, let's say you've gotten the time where it hit its highest point. If you substitute it to this, the formula for the x, you will get the distance on the horizontal where it hit its maximum height. And if you substitute the time where it hit 0, you will get the distance that it traveled, like the whole thing. And that's about it. Also for the quadratic formula, I mean, yeah, this part, let's say this is h. Looking at the time, since there's a plus minus, always remember, if you're looking for the time at the left part, use minus in the quadratic formula. But if you're looking for the time in the right part, use the plus side, since that's the further end. So yeah, I think that's everything.